Alright, humans, by now you should have an understanding of how the paradigm works and the difference between inheritance and composition. However, you may have noticed that a little bit of an issue with these, with this whole idea about generic stuff is that eventually you will simply have too many things and basically nothing at the same time. That's why, of course, it's abstract. Now, if we take a look at this example here I've set up, so we've got a spaceship, which let's say has one, two, three, well, I think I got it right, 7 properties, right? These 7 properties could be their own classes. If I want to, let's say we take a look at the crew, and I want to like break it apart, the crew into, I want to see how many doctors I have, how many pilots, how many engineers, security, robots, all that jazz. So the crew really is something that could be a class in itself. However, in my case, let's just say I'm interested in the amount of crew that I have. I'm not really interested in anything else. I simply want a number. So my crew will be represented by a number. And afterwards, whenever I address and write down, well, crew, and I will essentially be working with that particular number. Okay. So I hope that's fairly self-explanatory by now. Now this means that I need to assign data to this sort of crew idea, right? This crew property. Let's say, and I think we should start from top to bottom. So we've got the number of engines for our spaceship. We've got the crew, the mass, the name, the operational status, the service time, and the engine type. So first of all, let's define some engines. Now, in this case, I have a variable, which is a variable, of course, is something that can change over time. It can be assigned a value. There's also constants, by the way. So in this case, this would really be a constant because it's a spaceship, right? It's only going to have so many engines. Unless, of course, you're interested in the number of operational engines, in which case that could change because, if something gets blown up and you have 3 and all of a sudden you've got 2, then a constant is not really going to cut it because a constant is very inflexible. It really is just a number. So let's just say that this number of engines is going to be a constant integer. So engines, and it will be holding, I'm going to say that I've got 4. Now these 4, this is basically an integer. In this case, of course, is going to be constant. In order for it to be constant, by the way, you need to actually have sort of an identifier saying, oh, this is a constant, right? This is a constant, like this. But this obviously is different depending on the language you use. And since we won't be writing anything, there really is no need for me to tell you where or how you would be writing this, since you can simply define that in Unreal Engine via drop-down menu whenever you create the variable. Now there's loads of different data types, and like I said, you can create your own. These are generally called constructs. For example, in this case, I have an integer construct. Now an integer construct, actually, let's just say we have let's just say we have 2 engines. 4 is too much. Oh no, let's say we have 6 engines. All right, let's stick to 6. Now an integer itself is 4 bytes of data. It can store 4 bytes of data. All right, that's essentially the maximum amount of numbers it can store. We're gonna go over that maximum amount right now. So let's just say I want to go ahead and check my crew. Now if we take a look and I'm just say, well, my crew is however many. Now this is also an integer. However, if I go ahead and exceed my 4 bytes of data, it's possible to create an error. Well, not error, but my value will basically flip from positive to negative. The maximum value for an integer is, and I will use this, I'll say that my crew is equal to that essentially, is 214748, what was it, 36 and 47. So this is the highest number you can have in an integer, right? Because it's only 4 bytes. Now, if I go ahead and make it an 8, this will immediately turn into a minus because an integer simply does not have the capabilities to store anything more than this number. That's why a lot of these games on Steam, if you take a look at their, their high scores, they're usually ints. And they're usually very, the regular ints, and therefore people just max out the score by just typing down this number, by editing the config file or the save itself, and then Steam reads this and just adds it to the scoreboard. And what happens is, yeah, you go to the top because this is literally the highest high score you can get. It's literally the highest value this particular data type can store. Now, there's other ways around it. Let's say you want actually to have a bigger integer, so you would use a short int, right? Maybe this is not big enough, which would be 16 bytes, 16 bits. Maybe you want a long int, which would be 32. Maybe you want a long int, which would be a 64. So the more you go, obviously this also takes more memory, but also it allows you to store more and more data in it. Okay, so that's pretty much what an int is. It's essentially an integer which stores just regular values. Notice that it only stores whole numbers. It does not store floating points. If you want to store a floating point, you might want to go ahead and use, let's just say we're going to go over our mass. So in terms of mass, obviously we want it to be precise, right? So this has to be the most precise type of floating point. Now there's two types of floating points. One is a float, which is 4 bytes as well, and is accurate up to 6 decimal places. So you could go ahead and go 0.0000001. This is the accuracy of your float. There's also a thing called a double, which is sort of a double-sized float, which is 8 bytes, and it also can store 15. It can store more, but it's basically accurate up to the 15th decimal point. So I'm not going to go ahead and just add zeros here. But in this case, we do want to have a very accurate mass. So I'm going to say that, well, my mass has to be a double, right? Since my double is the most accurate low memory data type. And I'm going to say that it is, I don't know, something like this. So it's going to be 352 point this many tons. Okay, so this is my mass. This is my exact mass of my spaceship. Then you've got a name, which is a fairly simple one. The name is represented by a string because, well, it's a series of characters, and these characters form letters. Sorry, these characters form words, and these words form a sentence, and that would be a string. So let's just say my name would be a string, which, by the way, I forget how many bytes it takes. I'm not sure. You have to look it up yourself. And I will call this string. Usually, it's, by the way, in parentheses. If, of course, you're actually writing this in an IDE. But I'm gonna call my spaceship the Drunken Clown. I think this is a reference to Family Guy. Anyway, is it a Drunken Clown? I think, yeah. But then after that, you've got the operational status. So the name is fairly easy, right? You just assign whatever it is you want to assign. Obviously, you would use the syntax that is appropriate for your particular language. Then you've got a operational status property. Now this property can be simply, it has two states, right? You're either operational or you're non-operational. So in other words, we need a yes or no value, which is a Boolean, all right? So I'm gonna go ahead and make a operational status. This would be a Boolean, aka bool. That's what it's also known as. This is a 1 byte long sort of, I should actually probably write this down as a double here, and the double bit here, that this is, wow, there's no space. Are you joking? For real, dude? Come on. Okay, maybe I will be able to write down the thing. Where's my double? It's 8 bytes. Okay, 8 bytes. Now our bool is, it's pretty simple. It's pretty simple. It's either yes or no, so it's only a single byte. And let's just say it could be, it's operational. Yes, it's operational. So currently our ship is operational. Then the service time. Now here we're going to use a float because at the end of the day we don't really care you know, about the milliseconds, but let's say we're talking in years, and we kind of want to have the years in decimal. So let's just say I'm going to use a float here, and a float is 4 bytes. And our ship has been operational for, let's say, 56.74 years. So let's just say that this is our operational service time. And then we've got our engine type, which would be a character. Because at the end of the day, by the way, this is not the best way of, even though these are properties, yeah, you should be writing properties like these, but in general, you can also be writing them like this. The camelback or whatever type style. So just, you know, use whichever convention that you want. So this is going to be a character, usually denoted by a char, and the character is 1 byte as well. And it's going to be the engine type. Since this is a you know, a sci-fi ship, I really don't know what kind of engine types they are. So I'm just going to say this is a K engine type. So 1 character, K engine type. It could be, by the way, anything. It doesn't have to be K. It could be this, right? Or it could be this, but it has to be it has to be 1. Okay. So let's go ahead and take a look at our spaceship. What do we have currently? We have 6 engines. We got the maximum possible int in terms of crew. So we maxed out our crew. Although, of course, you could use a short, long, right, whatever. It's pretty heavy. It's got it's 352 point this many tons without the sort of the T in the middle. Its name is the Drunken Clam. It's currently operational. It's been in service for 56.74 years, and it's got a K-type engine. So as you can see, I've just defined a spaceship that, yes, as you can see, it's not generic, because how many spaceships can you get with the exact same mass, with the exact same service time, and with the exact same crew, with the exact same engine type, right? See, all of these things make my spaceship unique, and even if I derive from it, I will not get quite as good a result as I want to. So let's just say maybe I could, for example, get rid of my crew and really create a class for the crew, and just have this as a crew anyway, where it's just the number, right? But it is assigned and calculated in itself. So let's just say I create a class that's got doctors, tech specialists, right? Engineers, pilots, security. Let's say these 4 you know, categories, and all of them have a particular number that has to be assigned. So whenever I create this this spaceship, I need to say, yeah, I've got this crew, out of which, I've got this many doctors, this many engineers, this many security, and this many pilots, and then have a function that will just calculate all together what's the size of my crew, right? Even though it's technically a property, it is actually a class on its own, allowing me to you know, assign different things to it. Okay, so these are the data types, but you might be wondering, well, this is all great and all, but is there anything, like, let's say maybe I want to keep some of this information away from the other spaceships, right? So for example, let's say we have a name here. Now this name should be unique to our spaceship. So if I create another spaceship and it also has a name, well, this could be a little bit of a problem, right? So this is kind of not what you want. That's why you have the access modifiers. Now the access modifiers sort of change the way your class operates. Well, not operates, but is being accessed. So there's 3 types in terms of the class, and there's 2 extra for functions themselves. The first of them is a public. So let's just, because these are variables, right? I could say, well, all of these are public, and by that I mean if I go ahead and create another spaceship, right? If I go ahead and create another spaceship, it could also use these very same variables, right? So you could add the same the name, the operational status, the service time, etc., etc. You can access them, right? Which is not the best, because if this spaceship changes something about these variables, it'll screw up my first spaceship. That's not what I want, right? So a public, maybe I could make my name public, because if I wanted to say create a catalog class, so let's just say I create another class here. Yeah. And this class, I'm going to put it over here, for example. This class would be sort of my database, or aka my vault, or my fleet. Let's just say my fleet. This is my fleet class. And this fleet class has only one job. It has to collect the names of every ship that I have, and, well, you know, it has to organize them and tell me which one is a, well, I could create a class ship here. Sorry, as in not the class of ship, but the type of ship. So it could be a destroyer, right? It could be a battle cruiser. It could be a corvette. So whatever, right? Corvette, that's what it's called. Battle barge, whatever. The point is that I could assemble a fleet by just grabbing the names and the classes of each ship that I have here. So allowing me to create a fleet and simply glance. And currently I'm going to have, let's say, a drunken clam. And this one will be, let's say, the rotten apple. Right? So I've got these ships here. And I want to basically grab these properties. I'm not even going to hook them up. I'm just going to put them here. So I want to grab these properties and feed them to my class here. Right? Where's my name? Feed them to this class, the fleet class, so that it can output and give me, maybe it has its own property in terms of size. So I would have created something like this. So it would be size, and that would be a sort of like a property in it, right? And this size would be essentially an integer, aka an int. So it would be an int, and then this size would be however many. Obviously, it would also have another one, be you know, a string, for example. Will have all the names, but it also needs something more, which we'll address in a little bit. It needs an array, but we'll be addressing this in a little bit. Just want to finish the access modifiers here. So if these things are public, if all of them are public, I can work with them to a degree, but it does create an issue when you know, because everyone can access it. Maybe this spaceship can change this name, and the problem is not visible immediately. But when you got thousands of spaceships, when you got thousands of people working on the same code, someone could by mistake change something that is public, and because you did not sort of make it properly protected, for example, you would get an issue. Okay. Now, there's the protected bit is actually fairly interesting. You see, there's two types of, there's two ways to have a private variable. Now, the private bit, for example, the crew, only this spaceship cares about this crew, how many crew it has, right? This other spaceship has no business altering this particular crew set. It has its own crew to worry about, all right? So this crew has to be private, right? I'm gonna basically could put something like a P here, or no, I'm just gonna leave it as it is. I'm gonna call, you know what? Yes, I know what I'm gonna do. I'm gonna use color. Color coding is great. So I'm gonna grab these two, and these would be public, so they'll be green. In other words, available to the rest of the world, as long as, you know, something references the ship itself. I'll move this down a little bit. Well, maybe not that down. So these are green. Then, for example, the operational status should also probably be green, because you do want to know if, by others, right, if this ship is operational right now. So you could say, yeah, that's green. Now, what you could do is perhaps you want to have your service time to be available to everything else that gets derived. So let's say this spaceship has, let's say it's an aircraft carrier, so it's a carrier spaceship, and every carrier in the spaceship itself will be able to use the service time of the spaceship in order to add it. So let's just say I'm going to create a new class here, which will be derived from my spaceship, since this is a carrier. So I'm going to call this as an interceptor. It's obviously not the best way to do it. You probably would want to be deriving an interceptor from a spaceship. But the idea is, I'm simply trying to prove a point here. If this is protected, so I'm going to make this yellow, orange. So this orange bit is only available to classes that are derived from the original class. Okay. So all these properties right now have different access modifiers. These two can be accessed by fleet. This one can only be accessed by anything that is derived from this class. So it could be an interceptor, could be another spaceship. You don't know. It depends, of course, what you want to be. It's kind of like a limited inheritance type deal. Okay. Then you've got the private. Now these, for example, are private. You wouldn't want to change them at any given point, and nobody really gives a shit about the amount of crew, the mass, and the number of, especially for the mass, right? Although they are changeable, generally speaking, they should not be changed by anything else other than the spaceship captain itself. So the captain says, oh, I want more engines, let's pump more engines. I want to be heavier, lighter, let's get rid of something, right? I want more or less people. So these are kind of they're only accessible, these three are only accessible. Oh crap, there's no way to actually, I really have to do this one by one. Are you for real? So they're only accessible to Mr. Captain himself, which means that it does create a little bit of a problem when it comes to our fleet, trying to figure out, well, is the crew, how much is the crew? Like, well, how many people do we have in our entire fleet? Now, there's another way to do this, is to essentially say, well, we could also create a getter and a setter. Generally, this is what it's done anyway. It's very rare that you want something else to be modifying or even having access to a private, such a key piece of information, such, for example, the crew itself. Now, the fleet does want to know how much crew does each spaceship have. How much crew does each spaceship have? Okay, which requires you to have a getter. Now, you could also have a setter, but in this case, of course, you don't want to be changing the crew, although maybe you could. So let's just say we create a getter and a setter. It's usually just one line when it comes to code. Essentially, it's a function that allows you to connect something to the crew. So instead of, say, the fleet asking the spaceship, and then from the spaceship directly controlling the crew, it would actually have to go ahead and talk to a function. Now, I'm not going to go into functions just yet, because I think we have to talk about them in the next video when we go about logical, the logical bit, since we're only talking about data types here. But we need to have a getter and a setter. I'm going to use a step, whatever here. So this is a getter, and I'm going to say, well, this will be able to get, and by the way, usually you just have the set as well. It's kind of like the interface between these things. So I'm going to go ahead and say, well, the get and the set will be able to interface with this thing. Right, so it can interface with this variable, which is the crew. So anything that calls it, for example, this fleet could call a get on the crew. In this case, this setter would be called, well, it could be called crew, right? Crew. This is a whole the name of the thing, okay? And this one would be public, of course. So this is a public getter setter, all right? Which means that because this is a public getter setter, and by the way, you can define your own logic between the get and the set, and that's the cool bit. It adds an extra step between the data modification and reading, allowing you to actually, maybe you could get a lot of stuff. Maybe even though this is simply one crew, which is the variable which you get out of let's say the crew subclass. Remember, if you had this split up into doctors, technicians, pilots, and security in a separate class, and you simply added them together in this class, maybe you want to break it down again back into let's say doctors and technicians, or at least the minimum amount of doctors, right? So you could actually have that logic inside the getter or the setter whenever you set the crew. So maybe the fleet decides there's too much crew here, we need to change it, but you could actually set it and modify it here. So the fleet essentially gives a request to change the crew, and the crew will be changed according to the rules outlined in the getter and the setter. There's no difference between a function and a getter and a setter, right? There's just different keywords when it comes to these things. But generally speaking, you don't want to be exposing these variables here. You want to have sort of like the same method that we used in Designer when we exposed different parameters. This is much like the same thing. You're exposing these variables, but through a filter, or sort of like through a different function, which is, by the way, possible also in Designer. We just didn't do it. In general, I think I don't even think in their code that actually happens, right? Whenever you expose something, you are actually setting your getter and setter to be public, or I think that's something like that, because it wouldn't make sense to have direct access to the variable itself. Okay, so the fleet has access to these things via a getter and a setter, so it can also communicate, which is, great. Then, of course, we need to talk about the private and the static. Now, first of all, the fleet should be available to everyone. It's a constant sort of class, right? Or whatever it is. Could be a class, could be a number. So the size of the fleet, this fleet, for example, it must be always available worldwide. So each and every ship, each and every commander, captain, whatever, they have to have that information. And it's important that this information is not withheld, and it's global. Okay, whenever you want something to be globally true and globally available, then you must create a static object. So let's go ahead and create a static object. This is going to be a static color code. Static essentially means that anywhere on this chart, so any type of anywhere within the program itself, this thing will be available. The problem with it, of course, is that it can also be changed. So when it's static, you might want to say, well, even though it's static, I still want to have a getter and a setter, because I don't want to be changing the size, for example, negatively. I only want to increase it. All right. I don't want to reduce my fleet size, although that's obviously a stupid thing. Now, generally speaking, static things are kind of tricky, because you could end up having too many statics, and you could end up creating a little bit of an issue when it comes to your code. Generally speaking, do not have too many statics, right? The only time you need statics is when it's something of great importance, such in this case, the size of the fleet, or maybe the position of the fleet itself, or maybe the amount of fleets that you have, right? These types of things could be, static. So that being said, we're pretty much over with everything except the one bit, and that is the virtual. However, that is more or less a function, and the virtual function is pretty much the same as protected. But if we think about this service type as a function, let's say this is a very simple function, right? This function, so this number is the result of addition, which adds combat time plus travel time. All right, so let's just say that this is what it is. Actually, let's do this like that. I don't know. So this is a combat time plus travel time. There it is. This should be probably just the one. Oops. Reverse, actually. And there we go. And this should be hitting the deck here, mate. There we go. Okay, so if I can only align this. So this is travel time plus combat time in terms of years. Now, if an interceptor, for example, wants to, this would be our virtual. So the virtual is going to be, we're kind of running low on colors here, but it's going to be gray. Or, well, is this gray even? Going to be gray like this. So this is a virtual blue. We forgot. Wait, there is actually a blue thing. So this is virtual, right? Now, the interceptor could override the travel time and the combat time to get its own service time. Okay. The idea behind a virtual is that, well, you assume that you will have to the other class will the derived class will actually have to override it. Okay. Obviously, this service time is part of the spaceship class. So whenever you inherit from it, presumably you should be overriding the virtual function, and will give you a different service time. So in this case, this virtual function could have something. You could probably add it to the interceptor's travel time and combat time and get the overall service time for the interceptor itself. There's really many different ways you could sort of work with that. Yeah, that's pretty much it, actually. Now that I think about it, there's not more to say about access modifiers. You got getters and setters, which should be public obviously, and should be involved in the whole getting and setting situation. Actually, I should probably use a more greenish result here, maybe like something like this. So this is a getter and a setter, but it's generally important to have some kind of structure when it comes to your programming. In other words, if I think that something needs to be global, I will assign it a static situation. Generally speaking, they used to be, there's like in many code languages, there's actually things like singletons and etc. to set up your own sort of game loops and game managers, etc. But this is all taken care of in Unreal Engine 4, at least when it comes to the code itself. Right. Okay, so that is basically it. I cannot think of anything else I can talk about, except that's pretty much it, really. There's nothing else, guys. Yeah. So I'll see you next time when we talk about functions and logical operators. Make sure to grasp this. Just run this thought experiment on your own. Maybe create something else other than a spaceship. Create, I don't know, a regular ship, like the one that's on water, or maybe a military base, right? Just create one like this. In fact, I implore you, go ahead on Draw.io, right? And simply start writing this stuff down, right? Make yourself a diagram where, oh, I have a military base. This military base must have a certain set of properties. Which of these properties should be their own subclasses? In other words, their own classes. And which of these properties should be, sort of permanent? So which of these properties should be private? Which of these properties should be public? Which of them have to have getters and setters? In other words, even though they're private, they need to be utilized by external things, such as maybe high command or whatever. Just go ahead and create yourself a small, you don't have to go gung-ho, because obviously it's just a sort of a mental exercise. But at the end of the day, you just want to be able be comfortably able to determine what kind of data type everything needs and what kind of access does your thing need as well. So if you create such as a battalion, something on the outside, they don't need to have all the information about the military base, but they need to have, for example, contact with the commander of the military base, right? In order to coordinate properly. Therefore, it's much easier to think of this in terms of different access modifiers in the same way you think of military information obfuscation. So if you think about it, not every soldier knows everything that is going on with high command. So that's the same thing here. You are the high command, and you decide who knows what and who gets to decide to change what. And that's important, because at the end of the day, if even you yourself, after half a year, dive back into your own code and you see, oh, look at this. For example, the size of my fleet. Well, I should change that, right? And you go ahead and change that, and it somehow hooks up into something else. You change this one thing, and then everything else breaks. Or you accidentally do something and just delete something that you're not supposed to be deleting, or zero something out. So there's definitely a risk when it comes to that. And actually, I forgot to make the engine type. Let's just say the engine type, well, it probably is protected. So maybe it's protected because at the end of the day, the interceptors are going to be of the same make, right? So the interceptors would know about the engine type as well. Maybe they have the same engine type, it's just smaller in terms of size. Anyway, the point is that that's exactly what you have to do. Make yourself a small little diagram, figure out which and what it is. Try to assign different access modifiers, and you know what? Use the same color coding that I did, right? Green is public, red is private, orange or yellow is protected, blue is virtual. Now notice that virtuals are only functions, and technically functions also could be protected. In fact, as far as I mostly have used, I've very rarely seen anyone use a parameter, in other words, an integer or a float or something, and make it protected. Generally, even though you can, generally it's just for functions. So if it's about functions, you want them to be protected and or virtual. And when it's about variables, you want them to be private, public, or static. And then you need to have a getter and a setter
whenever you have some private stuff that you want to be talking about with something else. And whenever you have something public, generally speaking, that's really a bad idea to have a particular, even in this case, you still might want to have a getter and a setter and have these things to be private. Okay? Right. That's it, guys. See you in the next video when we talk about the logical operators and, you know, sort of create a little bit of a program, pseudo program, right? Bye-bye.